In this video, we'll see how to graph a quadratic function. So the first thing we're going to do is we're going to identify our a, b, and our c components of this function. So a is 2, and b is 4, c is -1. And we already know something about this function now and its graph. Since c is -1, that's the result we get for y when x is 0. So I know when x is 0, I found my y-intercept. It's down there at -1. Now I'd like to find my axis of symmetry. To do that, I take -b, which is -4, over 2 times a, or 2 times 2. -4 over 2 times 2 is -1. My axis of symmetry is at the line x is equal to -1. So my parabola is going to mirror across that line. I can also find another piece of information here. Since my axis of symmetry is at -1, that means I know the x-coordinate of my vertex. So let's think about this. If I have a function and I know the x-coordinate, or the x value, then I can calculate the y value. So y will be equal to 2 times -1 squared plus 4 times -1 minus 1. Again, because I know the x-coordinate of my vertex is somewhere on that red dashed line, the axis of symmetry, then I could figure out the y-coordinate of my vertex. 2 times -1 squared is 2. 4 times -1 is -4 minus 1. Y will be equal to -3. So now I found my vertex. It's at -1, -3. And then here's the great thing about the axis of symmetry. If I look at my y-intercept and it's 1 unit to the right of the axis of symmetry, then it's got to mirror 1 unit to the left of the axis of symmetry. Now let's just find one more point so we can make a more accurate graph. Let's find out what y is equal to when x is equal to 1. So if x is equal to 1, y is equal to 2 times 1 squared plus 4 times 1 minus 1. 2 times 1 squared is 2, plus 4 minus 1. When x is 1, y will be equal to 5. When x is 1, y will be equal to 5. And again, I can use my axis of symmetry to help me graph. This point here, 1, 5, is 2 units to the right of the axis of symmetry, so it must be mirrored over here 2 units to the left. And this is enough for me to make my parabola. It's going to look something like this. It's a beautiful non-curvy parabola there. All right, let's take a look at another example. Again, let's identify the a, the b, and the c. And let's plot what we know. C is -3, so I know my y-intercept is here at -3. My a is -2. What do you know about my parabola? If you said that it's going to open downward, or that it'll have a maximum, you are correct. When a is negative, the parabola opens downward. So let's find the axis of symmetry. -8 over 2 times -2. -8 over -4, that is +2. My axis of symmetry is at x is equal to 2. So right here. And now that I know that my vertex is somewhere on x is equal to 2, I can find my y-coordinate of my vertex. Y is equal to -2 times 2 squared plus 8 times 2 minus 3. Well, 2 squared is 4. -2 times 4 is -8 plus 16 minus 3. -8 and 16 is 8. 8 minus 3 is equal to 5. So my vertex is at the point 2, 5. 2, 5. Here is my vertex. Now I can find another point on my parabola My y-intercept is 2 units to the left of the axis of symmetry, so there's another point 2 units to the right of the axis of symmetry. All right, and let's find some more points on this parabola. Let's see what y is equal to when x is 1. Negative 2 times 1 squared plus 8 times 1 minus 3. Negative 2 times 1 squared is negative 2 plus 8 minus 3. Negative 2 and 8 is 6. 6 minus 3 is 3. Another point on this graph is 1, 3. So 1, 3. And now I know the point that mirrors across the axis of symmetry, 3, 3. And this is enough information for me to make my parabola. See if you can apply what you know. During halftime at a basketball game, a slingshot launches t-shirts at a crowd. You can find the height, h, of the shirt at t seconds with this function, negative 16t squared plus 64t plus 5. You want to figure out how long will it take for the shirt to reach its maximum height, and what is the maximum height. Before you go and start figuring this out, just think about, what does this graph look like? It's a parabola. A is negative, so you know it opens down. The y-intercept is at 5, so let's just sort of sketch out what this might look like. Maybe it looks something like this, right? That's our parabola. All right, let's see if you can figure out how long will it take for the shirt to reach its maximum height, and what is the maximum height. Think about what part of the parabola you need to figure out. If in looking at the picture you thought, hey, I need to find the vertex of this parabola, because that will tell me its maximum height, since my y-axis is the height, and if I can find the x-coordinate of my vertex, the x-axis represents the time in this problem, then I would find out how long it takes to get there. So to find the maximum height, we need the axis of symmetry. Let's figure out a is negative 16, b is 64, c is 5. So axis of symmetry, negative 64 over 2 times negative 16, negative 64 over negative 32. My axis of symmetry is at 2. Well, what did we just figure out there? We figured out the x-coordinate of our vertex. We know that it's going to take 2 seconds to reach the maximum height. That's how long it will take. Now, what is that maximum height? That is my y-coordinate of my vertex there. So let's substitute this in here. H of 2 is equal to negative 16 times 2 squared plus 64 times 2 plus 5. Negative 16 times 4, that's negative 64. 64 times 2 is 128 plus 5. Negative 64 plus 128 is positive 64. Positive 64 plus 5, 69 feet is the height at 2 seconds. And this is how we graph quadratic functions.